All right, let's look at our last two examples. So it says nitrogen gas diffuses from a container in 40 seconds. And a second gas, we don't know what gas that is, diffuses from the container in 47.76 seconds. So we can already tell that this unknown gas is a little bit slower. It's taking it more time to do that. What is the molar mass of the second gas? We're looking for that unknown. So we know we got to eventually use Graham's law, but this time we've been given time of the two gases. And so on the previous video I said if you have the two times you can always find the times faster, and so that is not Graham's law. When you find that, it's just time. So I can do 47.76 seconds, bigger number, divided by the 40 seconds. I'm not doing square roots because this is not molar mass. I'm just comparing the time. And when I do that, I can get 1.194. So what this means is that my nitrogen is this many times faster than unknown gas. So if you have time, you don't need Graham's law at all. But I'm going to need Graham's law because the question asked for molar mass, and Graham's law is the one that has the molar mass. But I know nitrogen's faster. I know how many times faster. So now I can take this 1.194 and stick it over here. Does that make sense? Okay, and then I've got to decide which one's on top and which one's on bottom. Nitrogen's faster. Nitrogen is diatomic. It is one of those diatomic elements. So it's not just 14.01, but 14.01 times 2. You get 28.02 gram per mole. And I don't know this. So we've got a scenario like we did on a previous example. The only difference is I had to use this to get to that. So switching to red, I'm going to square both sides. That just gets rid of the square on this side, and I can get rid of my units for now. And then I would tell you, probably just leave this number in your calculator. I'm going to go ahead and write it down so you can check yourself. All right, and then I've got to get that over there. That will cancel, and we'll go ahead and round to 2 significant digits there. And if I ask what is the identity of this, we could look on the periodic table. If I said this is an element, this would be gram per mole. And this element is actually argon. If we looked on the periodic table. All right, so that's that example. Let's look at our final example. So here we are. We've got some times again. So what can you do if you've got times? You can take the bigger time over the smaller time. And that's going to give you the times faster. So if I divide these out, I don't need to do square root. Remember, only do square root if they're molar masses. You get 1.1171, if I can read my writing correctly. All right, so that's going to tell me that it says argon is taking 39 seconds. So it's the slower one. So now my unknown is this many times faster because argon than argon. Okay, so this time the reason I want to do this one is to show you where it's very similar to the other one, putting that number there, right? So this time the unknown is the faster, so my x is here. Students tend to have trouble when their x is there, and so then we would get 39.95 gram per mole. So how are we going to solve it? Well, we're going to square both sides, right? And when you square this side, it just makes it go away. That x being on bottom is the troublemaker here. And let's see if I wrote all that out. 1.2479121. All right. So anytime your X is on bottom, it's called the reciprocal, and if you know what that is, that works fine. If you're not sure, you could put this guy over 1, and you could do some cross multiplication here, and that might help you. So you could see that you're going to get 1.2479121. X equals 39.95. And I would need to divide both sides by that number. And again, a lot of times I just hold that in the calculator. And I will find this is 32.01 gram per mole. And I could always check myself, right? I can put it back in and see if it equals that. Very checkable. Which element would this be? Well, if it was a pure element, this would probably be oxygen. Oxygen gas because it's diatomic, right? So, all right, that is our last example for Graham's law.